Okay, here we go. First example. If you could please write that down. Y'all know the parent function on this? Starts with Q. Ends in a C. The parent function. Yes! Yay! And what kind of shape does it make? Parabola, yes. I'm not quizzing you on the parent function, but it's nice to envision that. You guys having a parabola on a coordinate grid. So we're going to solve it, and when we solve, just like anything else, it is finding the zeros. So if it's factorable, let's factor it. It has an exponent, let's set it equal to 0. The 3 is getting moved to the other side. So this is a quadratic for sure. Not a test or quiz question, but it's nice to envision a parabola on a coordinate grid as we work through this. So x squared minus 6x minus 27, because I moved that 3 over. Is that factorable? It sure is. Numbers that multiply to a negative 27 that combine to a negative 6, that's going to be a negative 9 and a positive 3. And I don't have to do any sliding or dividing because the a value is just 1. So if I was solving this, guys, these would for sure be the factors if it was just an equation. X would for sure equal a positive 9 and a 3. A positive 9 and a negative 3. But it's an inequality. And guys, inequalities have infinite answers. So we've got some work to do. So what we're going to do is we're going to test some points. So I'm going to make a really basic number line. And when I say basic, I mean basic. All I'm putting are my answers. Negative 3 and a 9. So once I put in those answers, I just broke this number line into 3 parts. So I need to test 3 parts of that number line to see if I get a true or false number sentence. So I'm going to plug in some values for x right here, some inputs, and see if I get a true number sentence based on the original power. Let's talk about inputs. What kind of numbers are less than negative 3? What kind of numbers would I plug in on this side? What's less than negative 3? Negative 4, negative 5, negative 100. Anything less than negative 3 is going to work. Remember, your mean pre-cal teacher doesn't let you use a calculator in this class. So I'm going to pick x equals negative 10 because I can do negative 10 times stuff in my head pretty easy. So I'm going to use that for that. And then my favorite test x value is here. What's in between here that would be so easy? 6 would work, but I don't know if I can do 6 in my head though. 1 is good too. I can even think of 1 that's easy. If you can ever choose 0, choose 0. And then, what's higher than 9? 10, 100, 20, whatever. Yes, I like to use 10 because I like easy stuff. So these are my test points. All right, here we go. So when I plug in a negative 10, I'm plugging it in right here. I'm sorry, I'm going to plug it into the original. Honestly, guys, it doesn't matter which line of work you plug it into, but I'll be consistent and plug it into the original. Negative 10 squared, that's going to be a positive 100. And then a negative 10 times a negative 6 is a positive 60. Don't forget you have that negative 30 right there. And I need all that to be greater than a negative 3. Is that a true number sentence? 100 plus 60 is 160. 160 minus 30. Y'all, is that going to be greater than negative 3? Yeah, it's going to be a positive number. So if that number sentence is true, then this section is true. I'm going to put a little baby t for true right here above this number line. Because all those values are going to make it true. Yay, my favorite. Don't blink, you're going to miss it. When you plug in 0, those go away. So it's going to be negative 30 is greater than negative 3. Is that true? Is that true? This section's false. Let's try 9. Or past 9. Let's try 10. So when I plug in a positive 10, it's going to be 100 minus 60 minus 30. Ooh, that's a negative 3. Y'all, negative 60 and negative 30, that's negative 90. This is like 100 minus 90. Is that greater than negative 3? Yeah, that's right, T for true. Okay, so that's work. That's not our answer. Our answer has to be an interval notation. So, look, it's not part equal either, but it does include infinities. So, it's going to be negative infinity to negative 3. And then you got a gap. Don't forget to draw this U because you got to jump some stuff. And then it's going to be from 9 to positive infinity. That's it. That's the answer. Okay, when it comes to rational equations, very important that you do not forget. That's why I love people that use a red pen. X cannot equal a 3/4. That is so important. That's going on the number line. But I'm going to do some other stuff. I don't want to forget it. That's why I really like using a red pen. Okay, speaking of other stuff, what I'm going to do is solve. And I can't solve when x is in a fraction, so I'm going to multiply by the LCD. The least common denominator is 4x minus 3. When I multiply 4x minus 3 to this side, that denominator and this are going to get all canceled out. So the only thing that's left is the numerator. Over here on the right side, guys, don't forget it's 1 times that. So this other side is going to equal 4x minus 3. You do not have an exponent, y'all. Just solve. Just do your thing and solve. So when we solve, this is going to be minus x plus 3 plus 3. Divide both sides by 3. All right. Remember, these are like crazy wavy branches with U's and L's and weird stuff happening. There's something going on at x equals 3/4 because that's your asymptote. So we have to figure out what's going on. That's going on the number line. So here's my silly basic number line. Here's 3. Here's 3/4. Boom, you just broke it into 3 sections, guys. So my first section, something less than 3/4. Ooh, I know. X equals 0 because that's my favorite. In between 3/4 and 3. Ooh, that's another easy one. What's an easy test point in between 3/4 and 3? 1. Yeah, let's do it. And then beyond 3, I'm just going to use 10. I could probably use something smaller, but I don't care. I'm just going to use 10. All right, x equals 0. Well, those just go away at the top. And that's going to be 6 over negative 3. 6 divided by negative 3, y'all, that's negative 2. Is negative 2 greater than or equal to 1? Is that a true number sentence? It's not. Thank you. Thank you, Gabby, for answering me. This is false. This is false. Let's test in the middle. X equals 1. All right, so x is going to equal a 1. 1 plus 6, that's a 7. I probably can't do all that in my head, so I'm going to write 7. And then 1 times 4 is 4, and 4 minus 3 is 1. So the denominator is 1. This is a whole number. Is 7 greater than or equal to 1? This is true. So plug in 1. 1 plus 6 is the numerator. Plug in 1 down here. 4 times 1 is 4. 4 minus 1 is 7. Is 7 greater than or equal to 1? Okay. Then this is true. 10, my favorite. When I plug in 10, the top is going to be 16. When I plug in 10 at the bottom, y'all, 4 times 10 is 40. And 40 minus 3, what's 40 minus 3? 37, yes. Okay. That's positive. But is it greater than 1? It is not. So this is false. And it's part equal. But is it really? Is it really all part equal? If I shade this on my number line, I could certainly include this. But do I color that in? No, I do not. So, what is x equal? X equals, open parentheses, 3 over 4, and then close bracket for the 3. And that is the answer. Please write this down. We're almost done. It's 10:34. Plenty of time. All right, so 1 over x is greater than 1 over x plus 5. You have 2 restrictions with my favorite red pen. X cannot equal 0 or negative 5. No, it cannot. All right, so after we state those restrictions, the next thing we're going to do is we are going to get rid of those fractions altogether. I am going to multiply both sides by the LCD. And guys, the LCD is just both the fractions denominators. Just multiply by both of those denominators. And the numerator is 1, so that's going to be pretty easy. When I multiply this times the x, y'all, the x's just cancel, and it's going to be 1 times x plus 5, which is x plus 5. Over here, the x plus 5s are going to cancel, so 1 times x is just going to be an x. Ooh. But you got to block out your restrictions. So negative infinity to negative 5, negative 5 to 0, and then from 0 to positive infinity. That is the answer for that. Now, let's go back to the steps for just a moment. Remember at the beginning, if you like steps, I've got steps that will work for these problems. Here they are. Number 1, if it is a fraction, you must find the restriction. I pluraled because there may be more than one. And don't you forget that restriction is going on that number line. The second step is, well, it's a fraction, so get rid of the fraction. So the second step is to multiply by the LCD. And then once you do those 2 steps, the rest is the same for every problem. So remember, guys, if it's a quadratic, if you have exponents, you better set it equal to 0 and factor and solve. If it doesn't have an exponent, you solve it like a junior high problem. After this, you are going to test points. And then you are going to determine which one is true or false. And then don't forget, I'm grading interval notation tomorrow. And Buddy the Bat, he's got a tip for you. For quadratics, and only quadratics, you're going to have a problem like x squared plus 6x equals 9 or something. You're going to have a problem, and you're going to have the inequality symbol, and it's going to equal an answer. If the inequality symbol is open towards the problem, it's considered an or statement. You're going to have two pieces. If it is open towards the answer, it's one piece, and it's considered an and statement. That's pretty much always the case. Look, first problem. It was open towards the problem. You had an or statement. You had two pieces. Where else did we do a quadratic? Right here. Look, it was open towards the answer. You only had a single piece. You didn't have infinity when it's open to the answer. You guys have a good day.